Namaste. Welcome to today's mathematics session. In the previous class, we were in finding the square root of a number by repeated subtraction method, and today we are going to do the same concept, that is in finding the square root of a number by prime factorization method. Then what is prime factorization? Prime factorization is nothing but a process of factorizing a number in terms of prime numbers. Then what are prime numbers? Prime numbers are nothing but the numbers having the factors as 1 and number itself. Suppose if I consider a number 2, then 2 has the factor as 1 and 2. Therefore, number and number itself. Therefore, 2 is said to be a prime number. If I go with the other number called 5, 5 is having a factor as 1 and 5 itself. Means it comes in 1 table and 5 table. Means number and number itself. Therefore, 5 is a prime number. If I take the another number like 4, 4 come across in table 1, 2 and 4, means it is not having 1 and the number itself as a factor. It come across in 1 table, 2 table and 4 table, means it is having the factors more than 2. Therefore, 4 is not a prime number. It is a composite number. So here are the natural numbers written from 1 to 100, and here the numbers are represented within the green sketch pen. Those numbers are said to be the prime numbers. You can see 2, 3, 5, 7 are said to be prime numbers because they have the factors 1 and the number itself. Means it comes in one table and in the same table. Therefore, they are said to be prime numbers. Here 11, 13. 11 comes in 11 table and 1 table. Therefore, it is said to be a prime number. 13 comes in 1 table and 13 table. 17 comes in 1 table and 17 table. 19 comes in 1 table and 19 table. Therefore, these are also said to be the prime numbers. From 21 to 30, 23 and 29 are said to be prime numbers. From 31 to 40, 31, 37. These two are said to be prime numbers. Then next 41, 43, 47 are the prime numbers from 41 to 50, and from 51 to 60, 53 and 59 are said to be the prime numbers. From 61 to 70, 61 and 67. 61 comes in one table and 61 table, and 67 comes in one table and 67 table. Therefore, they are prime numbers. 71, 73, 79 are the prime numbers from 71 to 80, and in 81 to 90, 83 and 89 are the prime numbers, and from 91 to 100, 97 is the prime number. So total from 1 to 100 there are 25 prime numbers. You can count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So from 1 to 100 there are 25 prime numbers, and remaining are composite numbers excluding 1, because 1 is neither a prime nor composite number. So now we will find the square root of a number by prime factorization method. Before taking the example and solving, there are some steps to be followed when we are finding the square root of a number by prime factorization. The first step is write down the given number into the form of prime factors. Second step is making pairs of prime factors such that both the factors in each pair are equal. Step 3 is write one factor from each pair. Write one factor from each pair. No need to memorize these points, children. Automatically when you start solving, you'll come across all this. Okay. Next, Find the product of the above factors, that is in step 4. Step 4 from step 3. Find the product of the above factors. From where? From step 3. Okay. The next last step is the product is the required square root. So these are the steps to be followed when we are finding the square root of a number by prime factorization method. Let me explain by taking one example, that is find the square root of 1156, that is 1156. By prime factorization will go. If we go for repeated subtraction method, it becomes lengthy. So we'll solve this question by using prime factorization method. First we'll factorize 1156. So when we are going for prime factorization, when we are finding the factors, prime factors, we need to remember the divisibility rule, which we learnt in class 6 standard. So this 1156 comes in 2 table. Therefore 2 is a prime. We know that only even prime is 2. So 6 is present in the ones place, which comes in 2 table. So I'll go with the 2 table. 2 5s are 10. 2 5s are 10. Since here we are having 11, therefore 1 is remaining. We'll give it for 5. Then it becomes 15. Then 2 7s are 14. Here we have 15. We know 2 7s is 14. 1 is remaining. Again I'll give it to 6. It becomes 16. So 2 8s are 16. So 2 is a factor of 1156. Means it comes in 2 table. Next 578. 578, again in the ones place we have 8, which comes in 2 table. Therefore again I'll go with the factor 2. 2 2s are 4. Since we have 5 here, so 1 is remaining. I'll give it to 7. 2 8s are 16. 2 8s are 16. Again 1 is remaining. I'll give for 8. It becomes 18. Then 2 9s are 18. Right? Then since odd number is present in the ones place, shall we check for 3? So checking for 3, divisibility rule we have, summing up of all numbers, that is 8 plus 2 10, 10 plus 9 19. 19 doesn't comes in 3 table, therefore it is not divisible with 3. Next prime number 7. So if we go with the 5 to have a factor of 5, in the ones place we have either a 5 or 0. So it is not possible in the 5 table. Let me go with the 7. 7 4s are 28, but 9 doesn't comes in 7 table. So we are not supposed to go with the 7 table also. Now we'll go for 11. 11 divisibility rule, adding up the odd place values and the even place values. So 9 plus 2 is 11. 11 minus 8 is 11 minus 8 3, which doesn't comes in 11 table. Therefore it doesn't divisible by 11. Next prime number is 13. 13 ones are 13. 13 twos are 26. So here we have 28. 26 means 2 is remaining. 29 doesn't comes in 13 table. Therefore it is not a divisible by 13. So next prime number is 17. So we know that 17 ones are 17. 17 ones are 17, and the remaining is 11, and 17 sevens is 119. Next is 17 ones are 17. So what is the first step? Write down the prime factors of the given number. So 1156 is nothing but 2 into 2 into 17 into 17. So these are the prime factors. Next is make pairs of each factors. Okay. Then 1156 can be written as 2 square into 17 square. These are the pairs. The third is write one factor from each pair. So square, you send it to the either side, it becomes, or 1156 can be written as 2 into 17 whole power 2. Last year we learnt a power m into b power m is nothing but a into b whole power m. Therefore 2 into 17. Then square, sending to the either side, it becomes square root, which we learnt in the previous concept. That is square root of 1156 equal to, write only once, 2 into 17. What is 17 twos? 17 twos 34. Therefore 34 square is 1156, or 1156 is a perfect square of whom? Of 34. Therefore the square root of 1156 equal to 34. This is how we need to find the given number by using prime factorization method. Hope this is clear for you with the example, right? Now we'll solve worksheet 3. The first main heading is given like this: find the square root of each of the following by prime factorization. We know that prime factorization is nothing but writing the given number into the form of prime factors. Clear? The first question is 225. 225 means square root of 225, because in the heading of the question he said that find the square root. So square root of 225 is question mark. That too, finding the square root by which method? By prime factorization method. So 225, since the number is ending with the 5, so I'll go with the 5 table, because we know that 5 is a prime number. So 5 4s are 20. 20, what is remaining? 2 is remaining. So 5 5s are 25. The next, again the number is ending with the 5 table, digit 5, so we need to go with the 5 table. 5 9s are 45. The number is ending with the 9. 9 doesn't comes in 2 table. Next prime number is 3, so it comes in 3 table. I'll go with the 3. 3 3s are 9. Then 3 1s are 3. Some may have doubt, madam, 225. Can I go with the 3 table first? Yes, you can go with that also, children. Now 225, I can write it as 5 into 5 into 3 into 3. Don't write into 1, because 1 is not a prime number again. Okay. It is a factor but not a prime number. Then 225 equal to 5 square into 3 square, because 5 is repeating 2 times and 3 is repeating 2 times. We need to make into the form of pairs. Then 225 equal to, this can be written as 5 into 3 whole power 2. Then this square can, if I send it to the either side, it becomes square root. Then square root of 225 is nothing but 5 3s are 15. So 15 square is 225, or 225 is a perfect square of 15. Now let me go with the second question, sub question 2, that is 441. He is asking to find the square root of 441. Then go with 441 in finding the prime factors. Since 441 is ending with the 1 in the units place, right? Means it doesn't comes in 2 table. Next 4 plus, to check with the 3, next prime number is 3. To check with the 3, add up all the numbers. 4 plus 4 8, 8 plus 1 9. So 9 comes in 3 table, means this complete is divisible in 3 tables. So 3 1s are 3, 1 remains. 3 4s are 12. 12 means here we have 14, means 2 remains. Then 3 7s are 21. Now check whether again it comes in 3 table. 7 plus 4 11, 11 plus 1 12. 12 comes in 3 table, means this complete number is divisible with 3 again. 3 4s are 12, 2 remains. 27 means 3 9s are 27. Then next it is ending with 9, means odd number. I'll go with the 3. 9 plus 4 13. 13 doesn't comes in 3 table, means 49 will not divisible with 3, means 3 is not a factor of 49. Next prime number 5, means one's place should end with either a 5 or 0. So it is not here, so it doesn't comes in 5 table. 5 is not a factor of 49. Next prime number 7. 7 sevens are 49. Yes, 7 sevens are 49. Then 7 ones are 7. So this 441 can be written as 3 into 3 into 7 into 7. Nothing but 441 equal to 3 square into 7 square. Then 441 equal to 3 into 7 whole square. Squares ending to the either side, it becomes square root. Square root of 441 is nothing but 7 3s are 21. So 21 square is 441 and 441 is a perfect square of 21. Now let me move to the third question. Third question, 529. Yes, is asking to find the square root of 529. So if I go with 529, since its unit place is 9, it doesn't comes in 2 table. Now check it with the 3. 9 plus 2, 11. 11 plus 5, 16. Does it comes in 3 table? Next prime number is 5. Should end with 0 or 5 in the units place. It is not so. It doesn't comes in 5 table. Next number is 7. 7 sevens are 49. 49, 50, 51, 52, 3. So 39 doesn't comes in 7 table. So 7 is not a factor. Next prime number is 11. 9 plus 5 is 14. 14 minus 2 is 12. 12 doesn't comes in 11 table. Therefore 11 is not a factor. Next is 13. 13 3s are 39. 13 4s are 52. And 9 doesn't comes in 13 table. So 13 is not a factor. Next prime number is 17. As we know that 17 square is nothing but 289. So it doesn't comes. Next is 19. 19 square is nothing but 361. It doesn't comes. Next 23. So 23. If I go with 23. 23 2s are 46. 46 in the sense again 6 is remaining. Then 23 3s are 69. Then 23 1s are 23. So 529 I can write it as 23 into 23. Then 529 is nothing but 23 square. Then square goes to the either side, it becomes square root. Then square root of 529 is nothing but 23. We know that 23 is a prime number. So I went directly for 23 table. So square root of 529 is nothing but 23, or 23 square is 529. Now let me move to fifth question, children. Do the fourth question by yourself. I'll go for fifth question. Fifth question, 7744, that is 7744. He is asking 7744 square root. So 7744, if I go, since it is ending with 4 in the units place, which comes in 2 tables, we know that 2 is a prime number. So I'll go with the 2 table. 2 3s are 6, 1 remains. 2 8s are 16, 1 remains. 2 7s are 14, 2 2s are 4. Then next 2 1s are 2, 2 9s are 18, 2 3s are 6, 2 6s are 12. Again ending with C, I'll go with the 6. Ending with 6, I'll go with the 2 table. 2 9s are 18, 1 remains. 2 6s are 12, 1 remains. 2 8s are 16. Again ending with the even number, so I'll go with the 2. 2 4s are 8, 1 remains. 2 8s are 2 4s are. Then 1's place 4, so I'll go with the 2 table. Don't go with 4 table because 4 is not a prime number. 2 2s are 4, 2 4s are 8, 2 2s are 4. So 2 1s are 2, 2 2s are 4, 2 1s are 2. Since 121, ending with 1 table, 1 in the units place, 2 plus 1 3 plus 1 4, doesn't comes in 3 table, doesn't comes in 5 table, doesn't comes in 7 table also. I'll try with the 11. 11 1s are 11. Then 1 remains. 11 1s are 11. then 11 ones are 11. Therefore, 7744 can be written as 2 square into 2 square into 2 square into 11 square. Then 7744 is nothing but 2 into 2 into 2 into 11 whole square. Then square sending to the either side, it becomes square root. Therefore, square root of 7744 is nothing but 2 2s are 4, 4 2s are 8, 11 8s are or 8 11s are 88. So 88 square is 7744, or square root of 7744 is nothing but 88. Now let me move to sixth question, 8281. Let me find the factors first. 8281 ending with 1, so doesn't comes in 2 table. Then 8 10 18 1 9 19 doesn't comes in 3 table also, and it doesn't comes in 5 because 0 and 5 it is not ending. So we need to check with the 7 table. 7 ones are, because 7 is a prime number, 7 ones are 7, 1 remains. 7 ones are 7, 8 9 10 11 12, 5 remains. 7 sevens are 49, 7 eights are 56, 2 remains. 7 threes are 21. Again let me check with the 7 only. 7 ones are 7, 8 9 10 11, 4 remains. 7 6 are 42, 6 remains. 7 nines are 63, and 9 plus 1 10 plus 6 16 doesn't comes in 3 table. It doesn't comes in 5 table also because it is not ending with 5 and 0. Next prime number is, after 7 next prime number is 11, so it doesn't comes in 11 table also. We'll check for 13. 13 ones are 13, 3 remains. 13 threes are 39, then 13 ones are 13. So 8281 is nothing but 7 square into 13 square. You can see here are the pairs, right? Then 8281 is nothing but 7 into 13 whole square. Square sending to the either side. Square sending to the either side becomes square root of 8281 is nothing but 13 sevens are 91. So 91 square is 8281, or square root of 8281 is nothing but 91. Hope this is clear. Now let me move to 7th question. 4096. So asking square root of 4000, the prime factorization of 4096. Since it is ending with 6 in the units place, so we can go with the 2 table. 2 2s are 4, 0, 2 4s are 8, 1 remains, 2 8s are 16. Again in the ones place it is ending with 8, so we can go with 2 table. 2 1s are 0, 2 2s are 4, 2 4s are 8. Again in the ones place we have 4, which comes in 2 tables, so again I can go with the 2. 2 5s are 10. I am taking 2 digits together here. At the starting I can take 2 5s are 10, 2 1s are 2, 2 2s are 4, ending with 2, so again I'll go with the 2 table. 2 2s are 4, 1 remains, 2 5s are 10, 1 remains, 2 6s are 12. Again ending with 6, which comes in 2 table, I mean even number, so again it comes in 2 table. 2 1s are, 2 2s are, 2 8s are. Again ending in the ones place with the even number, so I will go with the 2. 2 6 are 12, 2 4s are 8, then 2 3s are 6, 2 2s are 4, 2 1s are, 2 6 are, 2 8s are, 2 4s are, 2 2s are, then 2 1s are. So all the factors are 2 itself here. So you need to be very careful when you are writing in the pairs. So I can write here 4096 is nothing but, I'll make the pairs at the factors near factorization only. 2 square, 2 square, 2 square, 2 square, 2 square, 2 square. How many times? 1, 2, 3, 4, 5, 6 times. So 2 square into 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 2 square. So I can write 4096 is nothing but 2 into 2 into 2 into 2 into 2 into 2 whole square. Then square root of 4096 equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. So 64 square is 4096, or 4096 is a perfect square of 64, or you can say in the other words is square root of 4096 is 64. So let me move to the 8th question, children. So moving to 8th question, that is 28900. That is square root of 28900. The question is, so let me write the factors of 28900. Prime factors. So 289 ending with 0, so I can go with 2 table. 2 1s are 2 4s are 8, 2 4s are 8, 1 remains, 2 5s are 10, and this 0 I'll write it as it is. Last zeros, if it is remaining, you can carry out like that only. Okay, even at the middle also, which we have seen in the previous question. Okay, again it is ending with 0. 0 comes in 5 table and 2 table also. Both 5 and 2 are prime numbers. Any one you can go. Since I have taken 2 in the previous step, so I'll go with the 2 again. 2 7s are 14, 2 2s are 4, 2 2s are 4, 1 remains, so 2 5s are 10. So in the units place you can see it is ending with 5, so I cannot go with the 2 table, or I cannot go with the 3 table. 3 table you can check like this: 7 plus 2 9, 9 plus 2 11, 11 plus 5 16. Doesn't comes in 3 table, so I'll go with the 5 again. 5 1s are 5, 6 7, 2 remains, 5 4s are 20, again 2 remains, 5 4s are 20, again 2 remains, 5 5s are 25. Again in the ones place it is ending with 5, I'll go with the 5 table. 5 2s are 10, 4 remains, 5 8s are 40, 4 remains, 5 9s are 45. And we know that 289 is a perfect square of 17. We know that 17 is a prime number again. So 17 17s are 289. Then 17 1s are 17. So here 28900 can be written as 2 square into 5 square into 17 square. These are the pairs. Okay. Then 28900 is nothing but 2 into 5 into 17 whole square. Then square of this all number, square will go to the either side. It becomes square root of 28900 is nothing but 2 into 5 into 17. Then what is the answer? 5 2s are 10, 10 17s is 170. That is square root of 28900 is nothing but 170. Or you can write 170 square is nothing but 28900, or square root of 28900 is nothing but 170, or 28900 is a perfect square of 170. All the meaning are same. So hope it is clear for you, children. So sub question 4, only one question is given for homework, that you can do it on your own. So this completes worksheet 3 first main, and from the second main we'll do it in the next class, children. Thank you. Have a nice day. Take care. Bye.